Biswas back with the new video. In the last few videos, we have discussed about the machine learning algorithms and the theory of deep learning. I have given a base like what all a deep learning thing can do. Today we'll learn about the artificial neural networks, that is the ANN. For this, a small thing about bio would be discussed. We will start with the neurons, which is in a biological term. A human brain makes the right connections with the help of neurons and dendrites. For example, since childhood, you are trained as a color as black and a color as red. Therefore, there must be something in your brain which actually goes. Maybe some chemicals. Some chemical reaction which actually helps it to distinguish between the two colors. Human brain is having 86 billion nerve cells which are called neurons. They are connected to the thousands and thousands of cells which are called the axons. The input to this is from the external sensory organs. For example, your eye is seeing a color. This is an external sensory organ. This input will create some electric impulses. These impulses will then travel with the help of these neurons, and at the last it will go to the brain. It will process it, and again through these electrical impulses it will get back. That means you are seeing a color. It will be processed by your brain. It will be transferred with the help of the electrical impulses. Again it will come back to your eye, and the brain will then say, yes, you are seeing a black color or a red color, and so on. This is the main architecture of the deep neural networks or the artificial neural networks as well. We are dividing a particular thing into number of layers, and that is why it is called a deep neural network, where the layer which is at the center is not a single. There are multiple number of layers into which the thing is divided. This is a biological diagram of the neurons, where the information is getting transferred, that is from one particular neuron to the other with the help of the axons, and the axons process it, and then again it gives to the dendrites and so on. The electrical impulse here is called the nerve impulse. This is how the biological thing takes place, but here we are here to learn the deep neural networks. Let's understand what is artificial NN, that is artificial neural networks. It is much similar to the biological neurons. Nodes will take the input, that is the data. For us, the input is always the data. Then it will perform the simple operations. Output at the node is called the node value. Each link will be associated with a particular weight. We can change the value of the weight and make our ANN learn. There's a diagram here which actually shows the input layer and then the hidden layer where the processing is taking place, that is our brain, and then the output layer where we can get the outputs. The weights play a very important role in this. We have to go to change the weights so that we can get the best output. If we consider a model, then the features of the model is a neuron gets activated when any one of the inputs are active, weights of each inputs are equal, and the output is binary. There are certain thresholds decided based on which the output gets triggered. Let's see with the help of a small example. In the first diagram, you can say there are three inputs, x1, x2 and x3. What we do, we say that these are as binary, and we decide that output would be 0 if the summation of wj xj is less than the threshold, and it will be 1 if it is greater than the threshold. Now, if we replace the value of the threshold with b, then the output equation becomes 0 if w dot x plus b is less than or equal to 0, and 1 if w dot x plus b is greater than 0. That's a very simple example. Now let's solve it. Let's say we are having two inputs, x1 and x2, and we are having the weights as -2 for both of them. Now, we have x1 and x2 as binary variables, so it can be 0 or it can be 1. Therefore, the various combinations will be 0, 0, 0, 1, 1, 0 and 1, 1. Now, this 3 is the threshold. Just see the output calculation. For the first, when x1 x2 both are 0 and 0, it is minus 2 into 0 plus minus 2 into 0 plus 3 is equal to 3. That means the output is positive. Similarly, when the values are 0 and 1, it is minus 2 into 0 plus minus 2 into 1 plus 3, which is 1, again positive. In the third case, when the values is 1, 0, that is x1 is 1 and x2 is 0, we see minus 2 into 1 plus minus 2 into 0 plus 3 equal to 1, which is positive. But in the last case, see, we are having 1 and 1, that is minus 2 plus minus 2 into 1 is equal to 1, minus 1. That means the output is negative. So now we can say, if my inputs are 0, 0, 0, 1 or 1, 0, in all the three cases, my output is positive. Now, if the threshold is considered to be 0 and if it is positive, then the output will get triggered. And if it is 0, it will not get triggered. So, we can see how a simple network with the help of the normal gates, we can do these calculations. So, weights and threshold, these are two important things. Then we'll learn about the activation functions. Activation function decides whether a neuron should be activated or not. It calculates the weighted sum and adds the bias with it. If I see the term bias, for example, if you have a normal model y is equal to mx plus b, where b is called the bias. The purpose of the activation function is to introduce a non-linearity in the output of the neuron. If we do not introduce any type of non-linearity, it will be similar to a normal linear regression problem, because the equation is again y is equal to mx plus b, which is similar to the equation of a straight line. But with the help of the activation function, we increase or we introduce the non-linearity. There are different activation functions. These are sigmoid function. You can see the graph. Tanh function. ReLU function. Softmax function. If I just randomly discuss about the ReLU function, see, it becomes anything whenever the input is greater than 0, we'll get the same as output, but anything which is less than 0, we'll consider it to be 0. The output will be 0 for that case. So this is the different type of ways where we are clipping the results based on my values. That is how much, when and where it should get triggered. Choice of an activation function. A difficult question. In maximum cases, the general choice of an activation function is the ReLU function. But if the output is binary classification, sigmoid function is the natural choice. If we start with the random weights. Now in a model, we are having some input nodes. Initially, we do not know the weights. We just randomly assign the weights to all my nodes. And based on it, I'm getting some outputs. Now, I should know from my training data what my output is. Now what I do, I take the difference between the input and the output. And based on this difference, we change the weight so that this difference can be minimized. We keep on minimizing after each and every iteration. This also introduces the concept of learning rate, which we will discuss in the further videos. Random weights will be there, it will give random results, we'll subtract the output from the input and have some result, and again to reduce this particular error or the difference between the output and input, we will keep on changing the weights so that the error is minimum. In the earlier videos also, we have discussed like the main aim of any algorithm is have the minimum error. Same with the deep neural network. This I've already discussed how we are calculating the difference and then changing the weights. So I think for now we are totally trained for the neural network. It's good to go. For the next videos, we'll learn what is different type of deep learning networks, what are the algorithms that we use. For example, what is CNN, what is RNN, how a text is recorded, how an image is recorded, how layering are done, and these things. Thank you for watching. Keep liking. Please subscribe our video. Thank you.